So I'm pretty excited here to have Christoph Worm to talk about Elastic Stack. So why don't you give me like the little 5-minute, like what is Elastic Stack, why it's important, and then what you're going to talk about it.
Sure.
Today.
Right. So Elastic Stack used to be known as the Elk Stack. So a lot of people still know it as the Elk Stack, and that's totally fine. The centerpiece of it is Elasticsearch, probably the most well-known piece. And it's kind of interesting that the story behind Elasticsearch. The story goes that the creator of Elasticsearch, Shai, was working in London while his wife was studying to become a chef, and he wanted to create a recipe search engine for her. And so there was no good open source tool available back then to do this thing. So he started creating something, and he called it Elasticsearch. And then other people, so it was a search engine. It was a full text, pure open source search engine, and he made it open source. He put it on GitHub. That was back in 2010, I think. And then people started using it. The community started picking it up, and one of the first bigger users of it was actually GitHub. GitHub uses it for searching through all the source code that is checked into all of the GitHub repositories, both on GitHub.com, but then also on all GitHub Enterprise deployments. And then other people picked it up as well. It's used as the search engine behind Wikipedia, behind all of eBay, and or behind Microsoft's MSN.com. So it's used as a search engine for a lot of websites, and that's where it all started. And then people found out that a search engine is actually also a pretty good place to put your machine data, to put your logs and your metrics. A search engine is very fast, has near real-time reads, has very high volume writes. It's easy to use. It has APIs for everything, and it also scales very well. And scaling means both scaling up and scaling down. So I can run it on my laptop, and in fact I do, or I can run it on 100 machines, and then of course I can have a lot more data in it and search through a lot more data. But still, all of the things that I just said are still true. It's still very fast. It's still very real time. And so people found out that, well, you can actually also use it for something like log data. And we had the community step up, and Rashid out in Arizona created a UI on top of Elasticsearch called Kibana. And Shai saw this and thought it was really cool, and reached out to Rashid and asked him to come on board. By then, he had founded a company around it, and so Rashid agreed and came on board. And then later, Jordan down in the Bay Area created a tool for getting log data into Elasticsearch called Logstash. And he open sourced that, and then Shai and Rashid saw this and found this really interesting, and so they offered him to join the company, and he did. So kind of back to what Ashley was talking at the very beginning of today, it's like writing open source actually can get you a job, right?
Yeah, you can make your own job out of it effectively.
You can make your own job, exactly, right? So this is one of the great hiring tricks, actually. We look at contributors, and then we just offer the contributors to join, and that's how companies like ours grow. But so that then became ELK, right? Elasticsearch, Logstash, Kibana. That's what the acronym stands for. And then we got some other software in, and so we dropped the ELK acronym and we renamed the whole thing to Elasticsearch. But basically, what it's being used, especially in the DevOps space, is for ingesting logs and ingesting metrics from just basically everything, right? Like most of the things that we've seen today, whether it's Kubernetes, whether it's resources created using Terraform or anything else, all of these servers, all of these containers, all of these VMs, all of them generate a ton of data, a ton of logs, a ton of metrics, and you need some kind of central place where you can put all of this and then look at it in just one central place. And that's basically what the Elastic Stack is about.
I see. And so I remember the Elk. I've heard about the Elk Stack. I didn't know that it was the search, the logging, and the Kibana, which is the UI over it. And the interesting thing is, now that I think about it, right? Usually logs, there's just these ginormous files that you're like, hey, where do we put these? And then the IT lady is like, hey, we're running out of disk space. What do we do with this stuff? And so this is interesting because my field is machine learning, and this is the kind of data that we use to create all sorts of machine learning algorithms. And so it's good. So I would love to see how this actually works. Do you have time to do a little bit of a demo for me?
I think so, yeah. Let's do that.
So
what we see here is we see Kibana. That's the UI. And this is kind of a preview, so it's version 6, which is going to be out in a few weeks, but we can already see it here. And so what we see here is what it looks like once you get the data in. So you have the data in Elasticsearch in the data store, and then you have the UI on top here, where the first thing that you see is you just see your data. You just see the raw data. So what we can see here is we just have this nice histogram at the top where we can see just the number of log events that we have over time. The data that we have in here is from our own website, elastic.co. This is like about 6 weeks of traffic on this website, about 14.5 million hits. And so we just have all of them in here, just standard web logs. We can look at the details of one of those events. If I expand this, then we can see the different fields, the different fields that are available here. Things like the number of bytes that was being sent. We also enrich the data, so we have things like the city name and the continent that we get from the IP address. We can look up the IP address in a database, and then we know where this IP address came from. And then, of course, all kinds of other things. The remote IP address that was being used, the response code that we sent back, the URL that was being used, and we can see it in this nice table form. But what we can also do is we can also see this in just the raw JSON. Everything in the Elastic stack, in all of these products, everything has APIs. All the APIs are REST and JSON, so it's quite easy to use as a developer.
So if you're like the question that I have is when I'm writing an application and I want to use the Elastic stack, right, to do all of this stuff, is there like a special? Do I have to add some extra code, or do I just use my standard logging procedures by putting things out to files? It looks like you're using Nginx here in this case.
Yeah.
Is there some special sauce that I need to make this work?
No, that's the beauty of it. So we have all these tools available that make it easy for you to use on your existing data, right? You already have the log files. All applications already log out something. Usually there's like log4j for Java applications. Other applications have their own standards. So there already are log files, and then all you have to do is you just have to configure something to pick them up, and then do maybe a little bit of like enrichment transformations, and then get it stored in Elasticsearch. But none of this requires code. All of this just requires configuration.
I see. And so as a developer, you just do whatever you do. Make sure you do a lot of logging, to make sure we know what your application, what's happening in your application. And then you can use any kind of hey, let's just pick these up and put them here.
Yeah, exactly. What's important though is like this concept of structured logging, where a lot of log data, to be honest, is just really unstructured. It's just a log line, and sometimes that can be problematic. Where if you have some fields in there and then a field contains something like an unescaped data structure, it's almost impossible to know like where one field ends and where another field starts. So the best thing to do is actually to log something like JSON. Or maybe key value, but JSON is the best. And like structured logging, then it's really easy to get the data into anything really, and to just do interesting things with it. But anyway, so going with the demo here, so we can look at the raw data, but we can do a bit more. So what we can, for example, do is if we want to see everybody who has access to a certain URL, we can filter down on this URL, and I can just click here, and then it creates a filter, a global filter, and it just filters down the whole view on just requests for this specific URL. And beyond that, what I can also do is I can have a search bar at the top. Like remember, it's a search engine, so it can do search, and I can just enter something that I want to search for. So for example, if I want to search for only requests, if I want to see only requests from, let's say, Seattle, I can just type in Seattle, hit enter, and then it filters down on that as well, and then I can just see the request from Seattle for this URL. Another interesting thing that I can look at is let's pick just any one of these requests at random. What I can do is I can look at what we call surrounding documents. Basically, the idea here is that when you're looking at something specific, when you're trying to find something specific, you might be looking for something like an error message. Like somebody called customer support, hey, I get this problem, I get this error message on the website, what's happening there? And so the operators go, the admin goes, you all guys who are watching, you go, and you look at your logs, and you want to find the error message, so you search for the error message. But then the error message itself is just one thing. What you probably want to look at is you want to look at, okay, what happened immediately before we got this error message? What was the action? What was being done? Which user was it? Which IP address? Which service did it hit? And so we can see here the context. We can see here the log messages that were immediately before and after the specific message that we selected. And what we can do here is if we want to, for example, filter down to a specific IP address, we can also do that. And then we can see everything that this IP address has been doing. So we can see that it requested a bunch of some blog posts and a bunch of assets, images that were probably linked to on the same page.
And this is cool because, like, as someone that's monitoring my website, I can actually see the paths that people go through my website. I can start to test things, and I'm assuming, and I don't know if this is true, that I could have this data queried via some other program to do additional analytics on top of that. Is that right?
Yeah, you can do that. Everything here is it's a very open system. You can just access all of the data via API. There's a query language behind it, JSON based. And we have language clients available for Java, for Python, for Ruby, for whatever you have. And you can just use that and just write your own little scripts and applications and integrate it with other things that you already have to access the data that is stored in here.
That's pretty impressive. So again, like you said, there's no real work that I have to do other than put out logs. And then what does the structuring look like? Like, let's just say I'm putting out like comma delimited files. Do I have to do some process that changes it to JSON to move it over, or will it read the CSVs?
We can read the CSVs. So we have a bunch of different input plugins for things like just standard log files, but also CSV files or XML files. Or we can also read data from databases. Like if you have something in a relational database and you want to pull it out of there and get that into Elasticsearch, no problem. We can also do that.
Fantastic. So is this the all of Elastic? Is there anything else you wanted to show us?
Oh yeah, definitely.
Let's do it.
So this is just looking at the raw data, and it's one thing that's really useful and that a lot of people are doing with it. But then the other thing that you can do is you can also create something more visual. You can create visualizations and you can create dashboards. So let me just show how that works. So on the left side here, I can switch into Visualize, and then I can create. I have a bunch of visualizations already in here, but I can create a new visualization. We have a bunch of standard chart types available here, things like area charts, different bar charts, line charts, pie charts, maps, and all kinds of things. I want to keep it really simple here, so let's just create a pie chart. Let me select that. Select the data type, so I want to select my log files. And one thing that, for example, would be useful to look at is look at the proportion of successful requests versus unsuccessful requests. So look at since this is Nginx weblog data, look at the HTTP response code that we sent out. So what we can do here is we can split this pie chart by an aggregation, and as an aggregation we specify a term segregation for a specific field. I believe it's called response code. Here we go. So let's split this by the response code, and then very simple. What we see here is that luckily, most of our responses seem to be successful. Over 75% are just HTTP 200. That's great. But then there's the next one is actually 404. So resource was not found. So that would be something interesting to look further into, and we'll do that in a second. And then a bunch of other response codes that we use here. And what I can do now is when I'm happy with this visualization, I could save it, and then I could take several visualizations and put them on a dashboard. And I believe I have one of the dashboards open here. Here we go. So I have a dashboard that I created earlier here that shows us a bunch of different things from the data. So instead of searching for looking at a very specific thing like what we see here at the top of the dashboard, it's just aggregated views. So I can see that in total I have almost 15 million requests. I have 850,000 unique IP addresses, unique visitors on my website. I can see a map of where my requests are coming from. I can see the pie chart that I just created with the response codes. And down here, I have a bit more detailed information where I'm looking at things like which browsers and operating systems people are using. Since it's a public website, there's a lot of web crawlers and bots and things like that on there. So a lot of the operating system, we can't really make sense of that. But then we have a lot of Windows 7 users. Many of them are using Firefox. Some of them are using Chrome. Windows 10, also pretty popular, has actually more Chrome than Firefox users, different from Windows 7. Some Mac users, some Linux users. And we can see the most common URLs, the most common resources that people are accessing. And not surprisingly, it's our icon. But also, we can see some really active APIs here. In fact, it's kind of interesting that the most active API here has almost 500,000 requests. I remember it's like 14 million requests here, so that's kind of a lot of requests. And what we can do here is we could look into what this IP address is doing. So if I filter down on this, then this whole dashboard filters down to just this one IP address, apparently an IP address somewhere in France, that has been active for only some period of time that we have data for, but made a ton of requests. But then actually, interestingly, it made almost all of its requests against just root. So I don't know, it might be the world's worst web crawler or something.
Yeah, I mean, that's impressive. So as I'm looking at this, and anytime I see like a tool that has this kind of power, I always feel like we need to like step out and level up. And how do I think of, because I mean, obviously there's so much I can do. What is some thought process that needs to go into like how I set this up properly?
Yeah.
Because I feel like there's got to be some overarching principles, like some stages of thinking about these things. How would you verbalize that?
Yeah, I can give it a shot. So I have a like it's actually my job, right? Like I talk to people the whole day. Like I used to be a developer, like I think everybody who talked today, like and I used to write code the whole day, and now I say like the whole day I just communicate with people.
Sure.
And so I talked to a lot of people, especially down in the Bay Area, about this. And the way I think about these projects is I think of them in three stages. The first stage is always getting the data in, ingesting the data. And it's probably the stage that you can most easily think about. It's also the one that you can most easily quantify and kind of measure by. And it's something that a lot of project teams spend a lot of time at. How do I get the data in? Now, there's two other stages, I think. The second one would be making sense of the data. And it's actually what I've been showing here, where just looking at all of the raw data doesn't really make sense. You have 15 million requests here, and that's just a demo. In a real world deployment, you would have a lot more data in there. So you need to somehow reduce all of this data that you have to something that is meaningful to you. And so there's two ways that I've shown here of doing that. One is to filter down to something specific that you're looking for, like the filter for the city, for the specific URL, what I showed first, and that's one way where we're using all these different data points to just the few data points that you care about. And then the other way, what you can do is instead of going down into the details, you can go up, which is this dashboard where you're looking at an aggregated view of the data, but no longer at individual requests. So these are like the second step, making sense of it, and then the third step is doing something with it. Right? There's usually two ways that people do something with these insights that they found. One is that they just do something manually. You see something in the data, like here we've seen this IP address, and now we could decide what to do about it. Maybe having 500,000 requests for the same thing from one IP address doesn't really make sense, so we might decide to, for example, block it, or we might want to further investigate. So that's the more the manual way. But then you could also do something more automated. You could have the system reach out to you, for example, in form of some alerts, like you might get an email if something like this happens, or if something like else happens, you might define thresholds and things like that. So these, I think, are the three stages: getting the data in, understanding the data, building your switches, building your dashboards, and then doing something with it, like building some alerts, for example, or establishing some kind of workflows or something, of reacting to it.
So I've seen how you do the, I see how you do the understand part. The ingest part, to me, that's still, is there some process? Is this part of Elastic Cert or the Elastic stack that does the import of the data, or is there something I have to do external to that?
Yeah. Good question. So let me show an architecture slide.
Let's do it.
And we can look into that. So what I have here is I have only one slide with me here, and let's see if this advances. It does not.
You can just
here we go.
There we go.
No, here we go.
There we go. Woke up.
The MacBook Touch bar actually saved me.
Oh, wow! There's one good use for it, right?
There is, yeah. Advancing PowerPoint slides when the trackpad doesn't work. Yeah. Right. So we see the kind of the like an Azure architecture for deploying Elastic on here. So on the left side, we can see how the data gets in. Now, there's two main ways that you can get the data in. One is to use Beats. Beats is a framework that we have, a collection of different data collectors. So these are small little agents just written in Go, so don't take up a lot of resources. They would run on the actual edge machines, on the either the virtual machines, or if you have containers, in the containers, and they would collect data, mostly log files, system metrics and application metrics, but it could also be things like network packets, and you just collect this data and just send it forward. Another way of getting the data in on Azure is we have an integration with a bunch of different Azure services. If you have some files already in storage blobs, then we can get the data out of there. If you're funneling your events through something like a service bus or Azure Event Hub, then we can get it from there. Or as already mentioned, we can also just pull data directly out of databases. So this is the out-of-the-box way of getting data into Elastic. And beyond that, actually, we already talked about the APIs, right? You can also you can go out and do whatever you want on your own, right? Like if you want to get your hands dirty and actually do some development, then you can, of course, also do that. And then what we have is you collect the data first in the left part. You might have to do some kind of enrichment. For example, for like logs, you usually have to do some kind of field extraction where you just have a big log line that has multiple different fields. It has a timestamp, an IP address, a username, and some other information, and you want to extract that into its own fields. And so that is something we can do in Logstash. And then we have Elasticsearch as the data store, and we have Kibana as the UI on top, and we've already seen that one.
What about XPack? What does that do?
XPack is the commercial extension that we have on top of the open source. So unlike some other open source companies, what we do is we don't have an enterprise edition of all of our open source components. We just have the open source components. And we just continue to develop them and release new versions of them. What we have commercially instead, we have commercial extensions on top, so basically as add-ons or plugins. So the nice thing there is you can just keep your open source installation as you set it up, and then if at some point you see that you can get value out of the commercial extensions that we have, which are things like security and alerting and monitoring and reporting and machine learning and these kinds of functionalities, then you can just install them on top, drop them right in, and you're good to go.
That's awesome. The other question I have is, with the volume of data that's coming in, do you get, like, is it real-time search, or do you have to shoot off a job and then things happen? How real-time can this be?
Yeah. It's fairly real-time. Like one of the reasons why I think this stack is so popular for especially log data and metrics is that you do need real-time access to the log data, the metrics. If something is going haywire in your anywhere in your IT landscape or any of your applications on your web servers, then you want to be able to debug now and not wait for some job to finish.
Right.
So even if you have a ton of data in here, and we have deployments of hundreds of terabytes of data, even sometimes petabytes of data, you can still expect this real-time response time. You just have to scale up your data store. Elasticsearch matters here, so instead of just having it on your laptop or on one instance, you would have dozens, maybe even hundreds of instances. But then it's perfectly possible. It's really designed to scale.
That's awesome. So you mentioned that it works on Azure. How does one set that up? Because I mean, this is a super interesting way of looking at logs. Yeah,
definitely. So what we have is, and I'm going to quickly show this here, is, let me switch back to my browser. So I have our Azure portal here that we have. And this is something that I would assume that every Azure user uses every day. And so to deploy Elastic, what you can do is we have a template. We've developed a template together with Microsoft where it's a deployment template. So it deploys a bunch of VMs and then surrounding infrastructure and configures them with Elastic, deploys Elastic on them, Elasticsearch and Kibana the UI configures them, and then you're good to go.
So it's literally just a click template and it's there.
It's basically like that. So like you just click on new, and then you can search the marketplace here. So let me search for Elastic. And when I search for Elastic, the first thing that should show up is, there we go, the official Elastic Stack template. So you just click on that. Gives you a bit of description here, and then at the bottom you can click on create, and then it takes you through this 8-step process of configuring everything. And I think I have it open here in another tab where I've already filled some things out. So you just configure things like the username and the password that you want to use to be able to access the VMs that are going to be deployed for you. You can configure how many nodes you want to have. You can configure which node size you want to use depending on how much data you expect to put in there. And then a bunch of other things, whether you want to deploy the UI. And then at the end, it gives you this nice summary that summarizes everything that you've configured. And then you just click on OK, and you after it has validated this thing, there we go, and you just click on OK now. And if I would do that, then it would now go, and it would create all of the machines, then create all of the application gateways and everything that is necessary to set this whole thing up. And then essentially you just have a URL and IP address that you can go to, and then you would see the UI that I was just showing. You would see Kibana, and then there's no data in it at the beginning, but then once you get the data in, you're good to go.
That's really cool. The other thing you mentioned, and it's because I'm a machine learning guy. You said something about machine learning. Can you talk a little bit more about that?
Of course. So we have we have this functionality that we call machine learning. Now, what it does at the moment is it does anomaly detection. When you have log data or metrics, then all of this is time series data. Everything has a timestamp associated with it, and so there's probably some kind of pattern to it. There's probably your data is not different every day, but you have just about the same number of visitors on your website today that you had yesterday, than you had last week. So then that means that you can do some very nice anomaly detection on there. And I can actually show it here. I have a demo of this.
Some machine learning robots here.
There we go. So I have the machine learning tab here, and we have a few jobs already configured, but I'm going to create a new job here. So when I create a new job, I have a couple of options for how to create it. Let's keep it very simple for now. I select my data set again, and then what I can configure here is it first asks me what I want to look at. So this is unsupervised machine learning, so I don't have to train it or anything.
Right.
But I just point it towards the metric that it should track. The easiest thing, what I always start with, is just the count. Just look at how many documents, how many events do we have here. And so if I do that, then I should be seeing here this is just an aggregation of the raw data, what we've seen before already. So just kind of like the normal up and down. And now what we're looking for here is we're looking for anomalies in this trend, in this time series. And so what I can do here is I will give it some kind of I will give it a name, and then I will hit create job. And as I hit create job, what it will start doing, it will start looking at the data as it has it and it starts creating a model based on what it sees, based on what it observes. And so it goes through very quickly through all of the data that we have here. Remember, it's about 6 weeks worth of data, some 15 million events, something like that. And it starts building this model. And it was actually pretty fast. It's finished. It found at least one anomaly. So let's look at the result viewer. Let me actually go to the very beginning first. So here we can see the learning phase. At the beginning, when it had just started building the model. It doesn't really know what the pattern of the data is. It doesn't know, is there a daily period, is there a weekly period, what are kind of the normal ups and downs, what are the normal values for this time series. So it just kind of is very naive at the beginning. It just assumes an upper and a lower bound, and this kind of seems to work for some time. And then after a bit of time, it starts getting smarter. Like here we can see how it got smarter, how it recognized that, oh, apparently there actually is a daily period in here. Probably since it's a website, we're going to have more traffic during the daytime and less traffic during the nighttime, just based on human psychology, or us having to sleep at night, unfortunately. And so the model becomes more precise, and then at some point it found an anomaly here where we can we usually have this seems like daytime. The number of users increases, and then suddenly it drops down hard. So what we can see here at the bottom is the actual anomaly that it has found, details about it. So we found an anomaly on February 27th, and we were expecting about 4,600 requests during this time period. I think it's about a 15-minute time period here. This would have been normal. This would have been expected. But we only actually have 281, so something went wrong, right? Like it's 16 times slower. And in fact, like some people might remember this, February 27th was the day when back when AWS S3 had an outage. Like the whole thing went down, and our website was actually tied to this in some weird way in the back end. And so, as many other people as well, we had a problem.
So that's a really cool, because it takes you from getting the data in, from actually visualizing, and then to actually getting some intelligence over that data in order to act properly. Yeah. That's awesome. Well, it turns out we also have a customer here that uses it. Anshul Kumar, why don't you come on over here, bud, and have a seat, and tell us a little bit about what your company does, and as well as how you use the Elastic Stack.
Well, thanks for having me here. So I work for McKesson Corporation. We'll move to the next slide. Touch bar.
Nice.
Thanks, Christoph. So McKesson, it's not many people know the name, but it's the biggest healthcare company in the United States and more than 185 years old. And work for the medical surgical business unit. And we have a quick map there. Those are our distribution centers that belong to my business unit. And our customers are physician offices, surgery centers. We are pretty much the middleman. So next time you see a McKesson van driving around, that's probably from one of our distribution centers, and that's our own private fleet. So Elastic Stack, I was talking to Christoph earlier, and he's like, what can you tell us about Elastic Stack architecture? And I had around 5 minutes to do it. So assuming engineers are smart people, I threw together this word cloud. So hopefully I'll try to speak to it, and people can hopefully search on it and get more details. So the first thing was bring your own license. So we have on the Azure ecosystem, you have a PaaS service, Azure Search. We did not do Azure Search because our use case is mostly about aggregate functions, and Azure Search does not give aggregate functions. So that's where we had to build it as an IaaS service. And as soon as you get into an IaaS model, then if you recall from a couple of minutes back, the Azure, like the template, the ARM template that Christoph walked to us, so that was our starting point. We deployed the first set of Elastic cluster through that template. Next thing we found out is building Elastic on-prem is very different than building Elastic Stack on VNets, right? Because Azure security, so as development group or the infrastructure team, we don't have access to tweak the private VNet on the cloud. That's done by a separate team. So it's imperative that we know about our subnets, and people who are in Azure, they know the subnet is the range. So if you think your Elastic Stack cluster, you want it to be 1,000 nodes to 100 nodes. Make sure you plan that subnet and ask the team to build you a subnet with that kind of IP space.
I see.
So, and on speaking about the IP, another thing is the security is pretty rigid. So you need to know your ports. On the Elastic Stack, 9200 through 9300, that's the basic requirement. But we got burnt on that. That's what we assumed. We built on that. Later on, we found out that the app team uses port 9500. So it's good to start a conversation with your own internal consumers. What ports are they going to hit the cluster with? Know it in advance, then later on. And one other thing that came up is we being in healthcare, security is of utmost importance.
Of course.
And I think traditionally our data centers are in complete lockdown. So no one gets in, no one gets out, right? So it's all easy. But on the public cloud, we had to make sure that we are only selectively opening up ports. And even within the Azure space, we have multiple VNets. Why is one VNet talking to another one? So on that side, we had to do plenty of research, and we are a big Hadoop shop, so we push data into Elastic through Hadoop.
I see.
The ES Hadoop 30, and we specifically opened only those IP addresses. Another thing that, which I can pretty much guarantee, as soon as you move from on-prem to an Azure and you try to run your Hadoop jobs, it's going to fail. And that's a highlighted red property.
Of course.
So make sure you add that ES nodes van only. What it's doing is it's making an entry on the ES nodes, and it's specifically telling the Elastic Stack traffic and the Hadoop traffic to hit only these nodes. So it's not searching for Elastic awareness all across Azure. The other problem we found out was in the existing Git template. In the PaaS model on Azure, you can scale up and scale down. And you can, when I say scaling, it's vertical and it's horizontal. Vertical is going to be bigger VM machine.
Right.
Horizontal is going to be more VM machines. And we don't have that functionality in the current world. And at the same time, if you are live, you're running a production cluster, people have tied their jobs to the load balancers, right, the static IPs. You cannot flip it on the fly. So it's imperative that you keep the same IP static. The only way we were able to find out to do this was selectively take down a machine, take out one of the machines and use the Azure Active Directory and the Azure space to insert one machine at a time. So hopefully it has the same host name and the same IP address.
I see.
And the one other problem on security is encryption at rest. So encrypting these machines takes, these are bigger machines, so it takes, don't be surprised if you're taking one full day, 24 hours, and just getting the OS part encrypted. The data it might run for 3 days. So try to put that buffer as you insert more machines and set up those expectations. And the managed cloud provider specs, so because we are a bigger enterprise, so we outsource our management of our IS assets on Azure, and we went with Rackspace. And earlier on, we thought, well, encryption is encryption, so we ended up doing BEK. Turns out that's not supported because the Rackspace backups were failing. They only support KEK. So that's another thing to set up expectations with your cloud providers. Like I said, each encryption 3 days. Better know it in advance than later. And we do use the Azure storage, blob storage. That's for disaster recovery and geo-replication. So in case of a DR, we can flip over the data and build a brand new cluster on the fly. And we did a drill. It takes around 60 minutes for us to go live on that.
Wow, so you actually ran through the failure and turning over, and it took 16 minutes.
We try to mimic it, yeah.
That's amazing. Yeah. I mean, this little 5-minute thing that you did is just look, here's some tips because we've used the Elastic Stack goodness. These tips and tricks, you should watch out for those. These are amazing. Any more you have in closing?
I want to do some fun stuff. The next one that I had was, so traditionally, I come from a data warehousing background, and the traditional approach on doing research or analytics is to first get the data, somehow load it into a relational database, and then try to kick off your joins and all that stuff to make sense of the data, how it connects together. And this became a challenge. Usually it's good with the little amount of data, but for projects like the Customer 360, where the data has not been looked out by anyone, this is the very first time someone's looking at it, I started running into issues where the unstructured data support does not exist. And the second thing is the field limitation, right? It can only take 1,000 characters and so on. So then it occurred to me, how about I throw everything into Elastic Index using Hadoop? I just separate indices, super simple, just load the data as it is, do not manipulate it. And towards the end, just drag drop each one of the indices into one dashboard pane. We just drag drop it. So that's what we did in the screenshot. Most of it is masked, but if you look closer into it, the first one is coming from our IVR system. That's our call center support calls, and there's an NLP behind the scene. I won't go into that. The next one is from our Salesforce.com engine, and we are also using the Net Promoter Score in here and our e-commerce website. So essentially, with minimal development effort, I think 6 hours of coding, that's what it required. I already had a BI visual dashboard, which I was able to send to my product owner. And he says, okay, how do I search it? And if you can type in the text box, you can search it. So there are no joins needed, nothing. So this was a good slingshot approach we got.
And this is impressive because it's coming from multiple data sources that are not traditionally in the same place.
Yeah, and the best thing was traditionally, IT builds a product, rolls it out, then business comes back to find out how can you validate it? It's doing the right thing.
Right.
So there's a second portion to the screen where we're exposing the complete indice. If business has a question, they can look at it because we did not throw anything out. So Elastic calls it what I'm going to call records. Elastic calls it document. The whole document is available. They can open it, click it, the entire email, and that's why it's showing up.
That's amazing. So a question coming in from the audience, are there any limitations on joins? Any guidance on making search queries not expensive from a compute perspective?
Yeah, so joins is an interesting topic. The question comes up a lot, does Elastic do joins? I know as an architect, I should never say no, but it's kind of no. The reason we don't do these arbitrary joins that something like a SQL database does is that, as I said, we can run on hundreds of nodes. And doing joins, arbitrary joins across these hundreds of nodes just doesn't scale. So there's different things that you can do. One, we can do some kind of pre-join. So what you can do is you can say when you put in 2 documents or more documents, some set of documents into Elasticsearch, you can specify a relationship there. You can have a parent-child relationships, and then we make sure that we store these documents all on the same machine, and then we can actually do in-memory joins, so then it works. So that's specifying it before, or alternatively, actually what many people are doing, they're not even doing that. What you can often do is you can just denormalize the data before you get it in.
Right.
Something like a log message, like the web logs that we've seen, an appear this is probably not just going to appear once in all your web logs, but several times. But we just store it multiple times, right? We're in a distributed system, we can store data, we can store a lot of data, and then of course searches are really, really fast. So it's different ways of dealing with this, but people usually find a way.
So no, but yes. No, but yes. You can do joins.
No, but yes, exactly,
no, but
right?
Yes.
Like
no, but yes, yeah. Took a little processing time. Well, anything else? Anywhere? Where can people go to find out more? Anything else you want to say about this?
Sure. I think the easiest way to go is just go to a website, elastic.co, and we have a ton of content in there, right? We have like documentation for all of these tools. We run at least like one webinar a week, oftentimes more. We have a very, very active blog which describes all of the features. Everything that I've shown here is something that you can look up there and you can look into. And hey, like if you ever like feel that you would like some additional help, right? Like just let us know, and we're happy to help.
Awesome. Well, thanks so much for spending some time with us, Christoph and Anshul. This has been amazing. This has been a really good Azure OpenDev. This is, unfortunately, the last session. Just a couple of things to call out. All of the sessions will be recorded and available on demand, along with Getting Started tutorials and labs at azure.com/opendev. So make sure you do that. Continue the conversation with our speakers on Twitter using the hashtag Azure OpenDev. And finally, if you're in Seattle, join us for the Azure OpenDev after party at I can't even read, man. Hard Rock Cafe at 6 p.m. Go to aka.ms/OpenDev after party to register. It's been a joy being with all of you. Thanks so much for watching, and hopefully we'll see you at the next Microsoft Azure OpenDev. See you then.